All right, so we're going to wrap up section 5.3 with a couple word problems. Number 6 says that Paige had $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. The felt costs 50 cents per sheet and the cardstock costs 75 cents per sheet. How many sheets of each can Paige buy? Now, when we're dealing with word problems with respect to systems of equations, often, but not always, we're going to have two equations, one that deals with quantity or total number of items, and one that deals with money. Now, in this particular case, we're talking about two different items that she's purchasing. She's purchasing felt and cardstock. And she's buying 12 total sheets of some combination of that. And her total amount that she's spending is $7.75. So we need to define our variables for what felt and cardstock will represent. So we'll let felt be X and cardstock be Y. So in terms of quantity, she needs 12 sheets of felt and cardstock. So if I take felt, number of sheets of felt, and I add the number of sheets of cardstock, it gives me the total number of items or total number of sheets for her scrapbook. So that's 12. Okay, so let's also define the variable. So let X equal number of felt sheets and Y equal number of cardstock sheets. Okay, so quantity-wise, number of felt plus number of cardstock needs to equal 12. Then in terms of money, the felt is 50 cents per sheet and the cardstock is 75 cents per sheet. So we're going to put the rate or the price for each item with its affiliated variable. And when I add them or I total them together, I'm going to get $7.75. So because felt is 50 cents, that means we're going to do 0.50x, so 50 cents per number of sheets of felt, plus the cardstock, which is Y, 75 cents per sheet of cardstock, so 0.75 Y. Needs to equal our total amount of that $7.75. Now, if we're looking to solve this system using elimination, I've got x plus y equals 12 and 0.5x plus 0.75 y equals 7.75. Now, I see 50 cents. If I double 50 cents, I have $1. And if I have $1, it's going to be the same, or 1, it's going to be the same as this 1x. So let's turn this 0.5x into a negative 1x by multiplying this whole second equation through by a negative 2. Okay, so we're going to take negative 2, distribute it through. So now my system will say x plus y equals 12. And now the second equation, well, negative 2 times 0.5 is negative 1. So just negative x minus 1.5y, if I do negative 2 times 0.75, equals negative 2 times our 7.75 is going to be negative 15.5. Now I'm all set up where I do have opposites and I can eliminate my x's. So now I've got 1y minus 1.5y, which is going to give me negative 0.5y, equals 12 minus 15.5 will give us negative 3.5. Just going to move over here. So now I have this negative 0.5y equals negative 3.5. we divide both sides by negative 0.5, which is going to give me y equals a positive 7. So we have half of our answer. We need to plug that in, find the other half, find what our x value is. Let's take that 7, plug it in for our y in our original. This one's the easiest one to go into, the quantity. So that gives me x plus 7 equals 12. And solving for x, we just subtract 7 from both sides. So x equals 5. So I have my ordered pair solution, but I've got to make sure I answer the question with respect to this ordered pair and the word problem. So how many sheets of each can Paige buy? So if we use our let statement, where x represented number of felt sheets and y was the number of sheets of cardstock, that means she could buy 5 sheets of felt and 7 sheets of cardstock. And what's this girl's name? Paige. Paige can buy 5 sheets of felt and 7 sheets of cardstock. Okay, so we need to take that ordered pair and write it using a sentence then. Okay, let's take a look at number 7. Screen around. Number 7 says Sally spent $14.85 to buy 13 flowers. She bought lilies, which cost $1.25 each, and tulips, which cost 90 cents each. How many of each flower did Sally buy? So we have another situation here where we've got quantity and money. So I'm going to kind of list those out, and our two variables are going to be our types of flowers. So we've got lilies and tulips. So let's let x equal number of lilies and y equal number of tulips. In terms of quantity, she's buying 13 flowers. So if she adds the number of lilies and the number of tulips, it needs to equal 13. So this is going to be x plus y equals 13. In terms of the money piece, well, what's the price of each? Well, the lilies are $1.25 each. So we're going to multiply 125 times x. Then we have our tulips are 90 cents each, so 0.9 or 90, doesn't matter, y. And the total amount that she spent was $14.85. Now, in this particular situation, it's not as easy to create opposites as, say, the previous scenario, because all I had to do was double 50 cents and I have $1. So I see that turning into a 1 versus the 1. So I can have a positive and negative 1 in the previous one. Here, I could make it work because 4 quarters make $1. So 4 times 0.25 is going to give us a whole number. 4 times 1.25 is 5. So then I could also create a negative 5x up here. But this is a good situation also for our substitution, where we just simply isolate one of our variables. So because the first equation has x plus y equals 13, they're all just 1x, 1y. Let's isolate 1 from equation number 1. So I'm going to choose to isolate x in equation 1. So if I do that, okay, so we're going to use substitution. If I do that, I would need to subtract y from both sides. So that means x is equivalent to 13 minus y. So we need to now take 13 minus y, substitute it in for x in our other equation. So that equation will now say 1.25 times x, which we are saying is 13 minus y, plus 0.9y equals 14.85. when we distribute in 1.25 times 13 is 16.25. Then we have minus 1.25y, drag down the plus 0.9y equals 1485. Before we go ahead with inverse operations, we want to collect our like terms. So I've got some y's on this right-hand side, or on this left-hand side, that we're going to bring together. So that gives us 16.25 minus 0.35y equals 1485. Now I'm going to isolate my y's. So I'm going to take this 16.25, I'm going to subtract it from both sides. And when we do that, we end up, going over here, with a negative 0.35y equals negative 1.4. And continue our solving process. We're going to divide both sides by negative 0.35. And that's going to give us a y value of 4. Okay, so don't panic if you end up with some like negatives, because as long as we have a negative on both sides, negative divided by negative will give us a positive through our solving process. So if y is 4, well, what's x? Well, I'm going to take that 4, we're going to substitute it back in to, because this was substitution, we can go back into our cloud, our little bubble here. We could plug it into one of the originals, that would work too. So that's going to give us x equals 13 minus our y, and y is 4, so x equals 9. So we have our solution in terms of our ordered pair, where these linear equations would intersect on the coordinate plane that represent this situation. But let's go ahead and write our solution with words. So how many of each flower did Sally buy? Well, if x is 9 and y is 4, it means she bought 9 lilies and 4 tulips. Okay, so situationally, you can see we use two different approaches in terms of the solving process in 6 and 7. So that's where we need to kind of know what our options are and what we're looking to accomplish for each in order to determine which method you should use when solving a system of linear equations. So you're not going to graph in order to solve a system unless you're specifically asked. Okay, so, and obviously that will be happening. If we are going to graph, we want to make sure that we solve each equation for y, put it in y equals mx plus b form, and then we're extra precise, and we're paying close attention to plotting very particular points using that rise and run. Substitution is a good method if one of our variables is already by itself, and then we can take its value and plug it into the other equation. Elimination is my favorite. We can use elimination when we already have opposites with our x's or opposites with our y's, or even if they're the same or the least common multiple isn't too much to work with. Okay, so elimination is, again, my favorite, and anytime you have opposites, definitely go with that. Okay, but we'll have lots of practice problems in our future that we'll kind of talk through and determine, well, which method would be the most appropriate based on what I'm dealing with.